Hello guys, welcome back to our channel Career at Market Value. I am Analyst 1. So the topic of today's discussion is estimating value at risk through MGARCH or GARCH M assuming a normal distribution. So first thing we have to estimate the long run bar, which we can pick from here. So I'll copy the format. Standard deviation will be square root of this, and since it's a normal distribution, this will be standard deviation multiplied by norms inverse, and for 95% it's 5%, and the same drill for 97.5, this will be 2.5% significance level. For 99% this will be 1% significance, and for 99.5 this will be 0.5. There you go. Now for the next set of values we will move to EViews for the estimation. So let's open EViews. So here's our EViews data. So we'll simply go to options, quick, then estimate equation, then simply write return space C, and the sample will give the end date as our the 70% data level that we will be estimating. So 70% data point is till 11th of November 2010. So I'll put this over here, 11th of November 2010, and make this as ARCH. Okay. So everything else remains same. This will be 1 1, ARCH 1, GARCH 1 will be 1 1. Model will also be GARCH and TARCH. And the only thing that we need to change over here is ARCH M, where it is written as none. We simply have to make this as standard deviation, and we need to click on OK. Error distribution should be normal since it's a normal distribution, and click on OK. So there you get your equation and the value of the coefficients. So we'll simply copy our coefficients. One is C, so let's put all the coefficients over here. C, value of the same is this. Let's make this as number from scientific. Okay. Then residual and GARCH. Let's copy both of this data. Then the values for the same. Okay. So there you go. Now I'll copy our equation, which is simply this. And paste it over here. There you go. So let's take this C3. Let's copy this first and paste it over here, C3. Then plus of C4, which is this coefficient corresponding to residual n minus 1 raised to the power of 2. So this is the coefficient. I'll open brackets, paste this, C4 multiplied by residual n minus 1 whole square. So residual n minus 1 is simply r this value, since this is the return. So this is residual n minus 1, and then it says residual n minus 1 raised to the power of 2. So we'll simply enclose this in brackets, raised it to the power of 2, again enclose this in brackets, and close the conjugate altogether. Then it says plus of C5, which is coefficient corresponding to the GARCH n minus 1. So coefficient corresponding to GARCH n minus 1 is this. We'll simply copy this, plus of close brackets C5 multiplied by GARCH n minus 1 or variance n minus 1, which is this. So close brackets, now press enter and convert this into percentage. So there you go. Now every other thing, say the standard deviation and the estimation of variance, estimation of value at risk through the different set of confidence intervals would remain the same. So you just need to copy this, paste over here, okay, and drag all these things down below. So yeah, paste this. So the estimation of value at risk through MGARCH, assuming a normal distribution, is completed. So I'll delete every other thing, say the equation and the coefficients. So there you go. Estimation of R, value at risk through MGARCH, assuming a normal distribution, is complete. We can go ahead and estimate students T as well from MGARCH. For that, we'll write over here, say students T for the students T distribution, and maybe I could also copy the width and maybe change its color as well. So we'll again go to our e-views to estimate the equation, right? Let's delete this and go to quick estimate equation, return space C. This is 11th of November 2010 for our 70% of the data. This should be arch, and the RCHIM should be changed to standard deviation, and error distribution now should be students T, and every other thing we should keep it as it is. Now okay, there you go, you got our equation and the coefficients. So first of all, we'll estimate the long run variance, which is this. Simply go ahead and paste this over here, maybe formats as well, and standard deviation, which is square root of this. There you go. Now we'll simply copy our coefficients one by one. First of all, degrees of freedom. So the degrees of freedom that we got over here is this, right? Then the coefficients one by one. There you go, the coefficients. then values for them. Okay, and the equation. So our equation is this. Copy the equation. So the equation states GARCH or variance is simply equal to C3, which is this value. So we'll paste this, then we put a equal to sign as well. Then C4 plus of C4. So we'll copy this and put one bracket. So C4 multiplied by residual n minus 1 whole square. So we'll again put one more bracket, and let's check our residual n minus 1, which is this term, right? Okay, and then square of this, so raised to the power of 2, and enclose this conjugate in brackets, and one more to close the conjugate. So this is done. Then plus of C5, which is this. So plus of brackets C5 multiplied by GARCH n minus 1 or variance n minus 1, which is this. So close brackets, enter. Maybe convert this into percentage. So there you go. Now for value at risk, since this is a student's t distribution, first of all let's copy the degrees of freedom, and for this we will be applying t inverse since it's a student's t distribution. So minus of t inverse, probability for 95%, 5% significance level, then degrees of freedom, close brackets, and multiply this with our standard deviation, which is this. So enter. Then copy this for 97.5, this would simply be 2.5. Enter. There you go. For 99, this would be 1% significance. There you go. And for 99.5, this would be 0.5. So done. So you can simply copy this and drag this down. Okay. And all these conjugate will down. Copy this. Paste this. Right. So our estimation of var through MGARCH, assuming a student's t distribution, is complete. We'll delete every other thing over here. Yeah. So we have, in this episode we have estimated value at risk through MGARCH, assuming a normal distribution, and a student's t distribution as well. So in our next video we will be estimating the last set of ARCH model for value at risk estimation, that will be IGARCH. So our estimation of var calculation will complete by then, and then we will move to backtesting in the next series of videos. So stay tuned for those content, guys, and do share, subscribe, and like our channel if you like this video, and do comment down below.